Okay, so we are beginning our equations topic, and our first lesson was solving one-step equations. This is the U-Try broken down in case you need to watch for any extra guidance. So before we begin these 6 problems, let's just reiterate that when we are solving an equation, we have to get the variable by itself. And so we need to do inverse operations to move the numbers over to the other side. So when we have addition, the inverse operation is subtraction. Just like when we have subtraction, to get rid of that, we would use addition. And then with multiplication, the inverse operation is division. So if we see something being multiplied and we need to get rid of that multiplication, we would divide both sides by that value. Okay, so for our 6 problems, remember, where you like to draw the line down the equal sign, that separates it into 2 sides. And what we do to one side of our equation, we must always do to the other side. So I'm going to go through these first couple, and we're going to stick with having an orange line, and that divides it into the left and into the right. So if I'm looking at problem 1, I have y plus 7. So the variable y is what I want to isolate. I put that in the box. I see what's happening to that y is that it's adding 7. And so what we want to do is we want to subtract 7 from this side to get y by itself. And if I subtract it on the left-hand side of the line, remember I have to subtract it on the right-hand side as well. And I will draw an arrow down. And so that's going to leave me with y. 7 minus 7 gives me 0, so that isolates the y. 8 minus 7 gives me 1. So it leaves me with y is equal to 1. And we can always check our work by plugging 1 in for y. 1 plus 7 is 8. In number 2, I want to isolate the w, okay? And so we see that 3, yes, it's in front of the w, but we are not it's not being multiplied because of that plus or minus sign separating. So they're 2 separate terms. And that 3 is positive. So what we want to do is we want to get rid of it by subtracting 3. So I'm going to minus 3 on this side. I'm not minusing 3 to the w. I already did it on that left-hand side of the orange line or my bridge. And now I'm going to subtract 3 on the right-hand side of my bridge. Okay? I draw an arrow down for my w. I bring that w down. 5 minus 3 gives me 2. I can then check my work. 3 plus 2 does in fact equal 5. Okay. Moving down to number 3, I want to get the z by itself. It says z minus 10 equals 13. So to get rid of that minus 10, to get the z by itself, the opposite of subtracting 10 would be to add 10. And if I add 10 on the left-hand side of that orange line, to keep my equation balanced, I need to add 10 on the right-hand side of that line. That's going to give me that going to 0. Whoopsie. I'm going to draw my arrow down. So I have z. 13 plus 10 gives me 23. If I go to check my work, 23 minus 10 is in fact 13. Okay, number 4, we have 6x. Now that does not have a plus or minus sign separating it, so they're glued together with multiplication. So I want to get this x by itself. And it is next to or connected with that 6 through multiplication. So to undo that multiplication, I need to do the opposite, which would be division. So the opposite of multiplying by 6 would be to divide both sides by 6. Okay, that's going to wipe that out, leaving me with x, because 6 divided by 6 would just leave me with a 1. Negative 24 divided by 6 would leave me with negative 4. Okay, so that is number 4. All right. And the last 2. Draw my lines down. So remember, if I'm doing one operation on one side, I have to keep my equation balanced and do it on the other side as well. For number 5, we have w divided by 2. So we want to get rid of that division of 2. So the opposite of dividing by 2 would be to multiply by 2. And if I multiply that left-hand side by 2 to keep my equation balanced, I need to multiply the right-hand side by 2. Those will go away. That's going to leave me with W equals 16. 18 times 2. Okay? And last but not least, we have 5/6 times x equals 10. So we could say, okay, that's really 5/6 times x. So the opposite of multiplying by that fraction 5/6 is to divide by that fraction 5/6. Or we have this shortcut that whenever we see a fraction being multiplied by a variable, we go into something called, I'll write this down over here, multiply by the reciprocal. So remember, the reciprocal of a fraction is when you flip the numerator and denominator. So if I want this to go to 1 5/6, I would multiply it by 6 over 5, because that's going to give me 30 over 30, and it will just cancel that out to 1. And now remember, if I do that on the left-hand side to keep it balanced, I have to do it on the right-hand side, okay? So when I draw my arrow down, x, that's going to leave me with 10 times 6, which is 60, all over 5, and that leaves me with 12, okay? Now, if you were someone who said, okay, well, I want to treat it like division of 5/6, right? Yes, you can just go ahead and type that in your calculator, 10 divided by the fraction 5/6. But if your teacher was making you do it by hand, whenever you have division of fractions, you multiply by the reciprocal. So if you remember that rule from your fraction operations, so you would end up with the same thing we have here if you were doing it by dividing by 5/6. Whenever we divide fractions, we multiply by the reciprocal. So that is our first U-try for our equations topic. Great job.